We're also going to be looking at ellipses with a center other than 0, 0, a center of hk. The h corresponds to the x term, the k corresponds to the y term. And to represent the hk with the standard form equation of an ellipse, you add or subtract the h value onto the x, and you add or subtract the k value onto the y. The a value is still the distance from the center to the vertex point. The c value is still the distance from the center to the focus point. The b value is still the distance from the center to the end of the minor axis. So if we look around here at the focus and the vertex, and really they have the endpoint of the minor axis, we'd see that we need to have the center along with A, B, and C in order to identify those points. If the major axis is parallel to the x-axis, that means that the larger value, the a squared, will be underneath the x squared. If the major axis is parallel to the y-axis, that will mean that the a squared, the larger value, is underneath the y squared value, the y squared expression. Let's go ahead and start off with example 3. We want to find the standard form equation for the ellipse whose major axis has endpoints -2, -1, and 8, -1, and whose minor axis has length 8. Let's start off by plotting these points. These points represent the endpoints of the major axis. So that tells us a lot. That tells us that this goes from -2 all the way to +8. That tells us the major axis has a length of 10. And if we cut that major axis in half, that gives us what a is equal to. So we have that a is equal to 5. So a squared is 25. Let's jump over here to this minor axis. The minor axis has a length of 8. Well, if we cut that in half, that gives us 4, which gives us b squared equals 16. The only thing else that we need in order to figure out the standard form equation of the ellipse is the hk value. And we can find that by going in a distance of 5, which is half of 10, to the middle here. And that gives us hk, which is when x is 3, y is -1. That's our hk value. And that gives us the standard form equation of the ellipse. We have x minus 3. Remember, we take the opposite to the power 2 over a squared. I know that we have the x squared over the a squared because the major axis lies along, the major axis is parallel to the x-axis. And we have y plus 1 because the -1 represents the k value. We take the opposite, y plus 1 squared over b squared, which is 16, equals 1. Alright, so if I wanted to draw this actual ellipse, I would need to go up a distance of 4, 1, 2, 3, 4, and down 4 from the center, and draw my ellipse here. If I wanted my c squared, if I wanted my focus points, which would be somewhere here and here, I would need to use the fact that a squared is equal to b squared plus c squared and solve for c in order to identify those points. Let's go ahead and do that for good practice, actually. So down there in blue, I've solved for c, and I found that c is plus and minus 3. So if I want to find my focus points, I need to add 3 and subtract 3 onto my h value. So let's see what that looks like. The focus points, one of them is when I take 3 and I add 3. The other one is when I take 3 and subtract 3 So we have one point at 6, -1, and then we have another point at 0, -1. Let's look at those in a sec here. So you can see here that I put my two focus points in bold because I made an incorrect guess the previous time. Alright, let's go ahead and move to the next problem here. We want to find the center, vertices, and the foci of the ellipse. The center, that's easy, right? We can find the center simply by taking the opposites next to the x and the y values. So that means that we have a center at -2, +5. That's our center. And let's go ahead and find the vertices. But let's get a picture of the ellipse. I think that will help us understand the different points that we come up with. Okay, so I plotted the center of the ellipse, and I've also written that a squared is 49 and b squared is 9. That gives us a and b. Because the 49 is underneath the y squared, that means that the major axis runs parallel to the y-axis. And to find the major axis endpoints, I'm going to have to go up 7. I'm going to have to go down 7. That's pretty easy to figure out what those points are just by looking at them. However, formulaically, we would simply add and subtract 7 onto the 5 to find those endpoints, the vertices. So there we have our vertices, and we can figure out our focus points using the fact that a squared is equal to b squared plus c squared. Let's go ahead and find the focus point. To find the focus points, we need the c value. So I found that c gives us plus and minus the square root of 40. So I'm going to have to add the square root of 40 and subtract the square root of 40 onto the k value of the vertex. Okay, so what does that mean? 5 plus 40, 5 plus the square root of 40, and 5 minus the square root of 40. Well, square root of 40 is somewhere in between the square root of 36 and the square root of 49, so that means 6 point something. So we would go up 6 here, and we would go down 6 here, and that would give us our focus points. Alright, so let's end there for now.